So welcome all of you. So this is our last video on this topic, molecular rearrangement and reactive intermediates in the organic synthesis. And we'll solve some of the problem based on the week 12 topic covered by the professor Shantanu Panda. And also revise the different problems based on the from 1 to in these core which is covered in this course. So before going to start to solve sample problems, so please let me know if anyone have any doubt regarding the topic which are covered by the professor. So the session is open for the any doubts. So make sure you will not have any doubt after this session because this is the last session, so you can clear your doubts. Yesterday, the professor has taken already a live class on the YouTube and uh, covered the queries from the students. And here also we are going to discuss with 12 some sample problems. So here is the first problem. So please stop me in between if you have any doubts regarding the any topic which is covered in this course. Not only from the week 12, but from in this course. So this is the last session. Here is the first problem. If you look at the questions, the given, so this is the first question. Predict major product form in the following reaction. And if you look at the starting material, so this problem is already covered in the last week. So this is the starting material which has the uh, double bond and the addition of the BH3 in place of the H2O2 and the base. So what will the product form in this reaction? So what will be the product form in this reaction? Does anyone have any answer for this one? So to solve this question, I will first show you the the addition of the BH3 across the double bond. So it was the last problem, but I will take that problem first. So I will take before going to that question, I will solve this question first. So this question is the addition of BH3 uh, to the carbon-carbon double bond is. So whether this addition is Marconi crop addition or anti-Marconi addition. So if you look at the BH3, the structure, that's the boron which has the three hydrogens. And if you look at the electronegativity of this boron and hydrogen, these hydrogens are generally the delta negative. So therefore, this delta negative attached to the carbon which has the delta positive character. So in this case, in the whenever we have such different alkene which has the one alkene has the here in this case methyl sulfate and another end of this alkene chain has the only hydrogens. So here there are only two hydrogens. So in this case, this is just modified structure that I draw here. So across this double bond, so the addition of this BH3 in takes place in this fashion. So this negatively charged hydrogen or the hydride goes to the most substituted carbon. So at this position, the hydride uh, get attached, and then the B, the boron atom attached to the delta negative charge, negatively charged transition state. So this is the stable transition state. So the partial charge distribution across these two starting metals will be in this manner. So the delta positive of this alkene line to the most substituted carbon, the olefin, and the delta negative on the least substituted part. And also in case of the BH3, the delta negative will be the proton will be delta negative and the boron atom will be the delta positive. So anti-Marconi crop addition is the pivot in case of the carbon-carbon double bond. And in this case, so this is the second question. So in this case, so what will be the major product form in this reaction? So this question that we have already covered in the last week. So I will directly tell you the answer. So which will be the answer? So you can go through the mechanism. So for this one, the option A is the correct answer. So the option A is the correct one. So work out with this one. So you will understand how this hydroxy group at this position come. Make sure you note down this reaction is in place of the uh, hydrogen peroxide. So uh, you will get the correct product in this one. So next question is based on the this question. So in this question there is NaNO2, and this question is also again covered in the last video. We'll go step by step in this case. So in place of NaNO2, this NH2 group convert into the this is the OH, and this NH2 group convert into the uh, N2 group. And then since this N2 is the good leaving group, so it will, so this N2 positive, and the since it is Cl, the counter anion will be the Cl negative. So this N2 positive, that it which is the good leaving group, the lone pair of the oxygen get involved in the double bond formation, and this entire bond migration takes place. So this N2 group releases, and it gives the formation of the six-membered compound with the so in the last step there will be a proton is eliminated, so it gives the final product, which is this proton is abstracted by the solvent. So this is the product we get in this reaction. Now the next question is the major product formed in the following reaction, which has the if you look at the starting material of this reaction, so it which has the bromine and the exosubstituted double bond on the 5-membered ring. So this reaction goes involve the first step is the radical formation because of this third butyl sorry tri-butyl ene and AIBN. So it forms the radical at this position. So in this case, what happens? So at this position, there will be a radical form getting formed. So I will just draw the structure. So this is the structure, and which has the double bond. And if you look at here, it has the two hydrogens that also I will draw. And because of this uh, tri-butylene and the AIBN, the radical gets formed at this position. The benzene is a solvent and under reflux condition. So once this radical form, so if you look at the the chain, so it has the 1, 2, 3, 4, 5, and the 6 number carbon. So there will be a cyclization step, and this cyclization step follow the 5 exoteric cyclization mechanism. And so this, I'll draw the different color better. So this double bond attacks on this position, so it gives the one 5 member ring, so which was earlier as it is, and newly formed 5 member ring in this fashion. So the radical now is formed at this position, which then obviously get converted into the neutral species by abstracting the proton. So this is the product formed in this reaction. So this mechanism is the 5 exo trig cyclation mechanism. So better I will draw here. So at this position, this attack is by 5 exo trig mechanism. The next question is uh, this is the fourth question. So if you look at the question, the major product forming the following reaction. So we have the uh, ketone, and if you look at the reagent, which is tosyl hydrazine. So tosyl hydrazine ethanol. So whenever this tosyl hydrazine interact with the ketone, it forms the. So let's say this is the ketone, it forms the imine, and NTS will remain. Sorry, NHTS will remain as it is in the product. Then we have added excess of butyl lithium. So this was the product of the first step. Then we have added the butyl lithium. So when you add the butyl lithium, it abstract the proton. So which proton get abstract? So if you look at the acidity of these protons present in the reaction, the alpha proton to the ketone group is acidic, and which is get abstracted by the butyl. And obviously, because the butyl lithium is in excess, the NH proton is obviously getting abstracted. So I will put the reaction mechanism there. Right. So the first step, the tosyl double bond formation, imine formation with the tosyl group attached on the nitrogen, which comes from the this our reagent. Then butyl lithium abstract the alpha proton, so it leads to the formation of the such double bond formation. And again, the NH proton is also getting abstracted by the butyl lithium, so it forms the. So this N2 minus N2 elimination also takes place in this same similar fashion, and we get the anion at the ipso position to the where we had initially the keto. And this anion, carbon anion, then in the starting we have the, in the third step we have the DMF, that's the formulating reagent. So when this anion form, it attack on the DMF, so which is the electrophilic center of this the carbonyl center of the DMF, and NH2 elimination in uh, Me2 elimination takes place to get the formyl group here. So the one thing to note here in this reaction, the first step is the well-known step. So the first step is the formation of the imine. The second step is the butyl lithium. Whenever we add the butyl lithium in excess, so these protons are available for abstraction. So, and again this NH proton also. So it can abstract the proton from here, and which leads to the formation of the carbanion at this position. So in this step, the carbon formation takes place. So this is the example with the symmetric ketone, which has the substituent at the here. So these substituent are in the starting material, but so therefore our life was easy in this example. So only the formulation takes place at this position. So this was the overall reaction. But in when we have the example with the uh, asymmetric example, let's say I will take the same question again. So in this question, the we will take first the correct answer. So the answer for this question is Option A is the correct option, right? As we have also the go with the mechanism, and we got the option A as the product. But in case, let's say there will be a, if there is a methyl substituent at this position, then what will be the product? So obviously, we know now these are not the correct product. So we'll just discard this all this. So whether this is the product with methyl at this position, or what will be another option? Double bond is here. Sorry, double bond at this position. Then CHO and this butyl as it is. So this is the product. So whether the A or the B, which one is the product? So you work out with this question. So we have now only the two options. So what will be the correct option here? So that you need to identify. And that's easy if you just go apply all the concept that you have learned in this course. Only the variation takes place here, the proton abstraction. So in I will just give you some clue. So what will be the so here there was methyl, right? So that methyl will be remain in the product, whether it is here. So I will draw here. So now this proton, whether it abstract this proton, or also there is one proton available, this proton. So which proton it get abstracted by the butyl lithium. So butyl lithium is not that much bulkier. Keep in mind. So the this butyl lithium is the C negative. So not much bulkier. So it can easily access these proton also. So depend upon the stability of these double bond. So which product get? So this is the one of the possible product, and the for the B, also draw the same reaction mechanism. So this is the B product, and what will be the reaction mechanism for that one, and which product will be the major product? So that you need to find out. And I will move to the next question. So this is the next question, and which involve the we have the SME3 group, OH group, and the here this OH group which is protected by TBDMS. And when you add the H2SO4, that's the strong acid, and in the second step the TBAF, tetrabutyl ammonium fluoride. So what will be the product in this reaction? So if you look at the reaction mechanism, in the presence of the strong acid, that's the H2SO4, what will happen? This OH get protonated. Obviously, it is hydroxy group, which has the lone pair. Oxygen has the lone pair. It get protected, and it becomes the good leaving group. Then in the from the solvent, the water attacks on the Si. So this will be the E2 elimination takes place to get the alkene. And in place of the tetrabutyl ammonium fluoride, the OTBDMS deprotection takes place to give the free OH hydroxy group. So here the three important steps. The first protonation of the hydroxy group. So this OTBDMS not get protonated because of this TBDMS bulkier group. And so this hydroxy group get protonate, and the water attack on the SiMe3 uh, in the and it takes the E2 elimination reaction in the concerted manner. So we get the uh, E alkene as a product, and then there will be last step, the tetrabutyl ammonium fluoride. used for the deprotection of the OTBDMS protection. Here, the next question, the major product forming the following reaction sequence. So we have the compound which has the two hydroxy group, one hydroxy protected by the benzyl protection, and we have the SiMe3 uh, group. And which, if you look at the SiMe3 group, so which is seen to alcohol. So I will just label this alcohol anti to alcohol A and the syn to alcohol group B, and we have added the KH. Now this KH is the again the source of hydrogen minus, so obviously a strong base. So when you add the strong base which abstract the proton, so this proton and this proton are available. So in this case, let's obviously it will not selectively abstract only this proton. So obviously there will be intermediate other also possibility. So it abstracts the proton from both O negative, but uh, B O negative uh, formed by the abstraction of the proton from this hydroxy group, which is seen to the SMI group. This O negatively charged, that is the attack on the silicon because it is in a syn fashion, so it is in close to each other. This group, so it forms this four-member ring, which then gives formation of the olefinic double bond. So in this fashion, so if you look at here, the bond movement you can observe, you can see from this structure. So this OSI bond get newly formed, OSI bond getting formed. Then once this bond form, it forms the four-member ring. So this four-member ring then get cleaved in the fashion. It S double bond O, ME. So this is one of the product form by cleavage of this bond, and another there will be a double bond form in the product. So this was the key step here. So this alcohol was anti, therefore it was not involved. So this one not involved in the bond formation with the Si. So therefore the position of this double bond is important in this question. So here there is a double bond, and now we have the in the next step what we have MCPBA, that is the metachloroperbenzoic acid. So this metachloroperbenzoic acid is used for the epoxidation reaction. So this is the benzene ring and this is the benzoic acid, and the meta 1, 2, 3. Here there is a chloro, and since we have the metachloroperbenzoic acid, so there will be a OH. That's the perbenzoic acid, and the proton, sorry, one of the oxygen from this perbenzoic acid get attached on the double bond. So let's say we have olefin, and when treated with the double bond, it forms the epoxide. So that's what the last step is. So this is the product. So hydroxy group from the hydrogen bonding with the, right. So in this case also, you also need to focus on the stereochemistry of the epoxide also. So in the formation of the epoxide, this as I shown the structure, this oxygen atoms forms hydrogen bonding with the hydroxy group present in the starting material. So this is the starting material which has a hydroxy group directing downward. So therefore, epoxy group formation also takes place on the same side as the hydroxy group in the compound. So that also you need to keep note. So this is the important point here. So the stereochemistry of the epoxide is driven by the the hydroxy group present in the starting material. So this was the reaction. I will take, so I think this was the question. This is the last question from the week 12, and then we'll solve some general question from 1 to 12 reaction. So here So here, this is again the reaction, simple reaction. Predict the major product forming the following reaction. So I don't think I need to describe this reaction. So this is just addition of HBr, but in presence of the peroxide that you need to remember. So what happened in place of the peroxide? So I think we should look at the detailed mechanism for this one. So in this case, when you add the peroxide, we know the HBr addition across the double bond, how it takes place. But in place of the peroxide, what happened? We get the anti-Marconi crop addition product. Why this? Because it goes via radical pathway, and this peroxide breakdowns in this fashion. It forms the OR radical. So here peroxide is ROOR, and this get cleave homolytically, gives the OR radical. Then this OR radical react with the HBr. It forms the alcohol plus Br radical, and this Br radical react with the alkene. So this is the alkene. So it Br radical attack on the carbon atom which has the uh, less number of hydrogen, sorry, more number of hydrogen atoms. So this is the or the least substrate one. So here at the terminal carbon it attacks, and the radical form in this up that this step is the tertiary radical, which is the stable radical, and then the HBr react with the this intermediate radical, that's tertiary radical. The proton abstraction takes place to gives the formation of the product. Right. So this was the simple step. So this is the basic difference between the HBr addition across the double bond. So if you don't have the peroxide in the reaction, so the only HBr, and in that case the product will be different. So what will be the product in that case? The product will be, so this will be, here there is the hydrogen, and here there will be Br. This is because it attacks via H. It abstract the proton, and it forms the intermediate step. So that intermediate step is the carbocation intermediate, and here there is a proton. Now this tertiary carbocation is stable, so therefore carbocation form at this position. Then in the next step, this carbocation get uh, the bromine attached there. So the bromine, here there is a CH3. Right. So these are the some problems for these week 12 topics. So I'll just remove this one because you may get the confuse in this one. So as we seen with the only HBr, we get the opposite product because carbocation intermediate formation in place of the only HBr without peroxide. But in place of peroxide, the reaction goes via radical mechanism. Here another question. So this question is not from only the week 12. So now I take the question randomly from week 1 to 12 topics. So this question is basically the type of Birch reduction. So here we know in the Birch reduction reaction, metal like sodium, lithium, or potassium, when these metals are in place of the NH3, liquid NH3, and it forms this metal the metal radical, which is stable by the NH3, this N type. N stands for, so there is not only single NH3 molecule. So obviously they will be all around. There will be a the NH3, and NH3 will be stabilize this M radical and one electron obviously. So this one electron attacks the aromatic ring. So in this case, so what will the product in this reaction? So if you look at the starting, we have the methoxy substituent and the ester substituent. So in this case, when this when it gives the electron to the system, so it forms the carbon ion at the meta position to the methoxy group and radical at the ortho position, that is to the ester. Now we have the T-butanol, which source of the proton. So it abstracts the proton from the solvent. So here there was only one proton. Now here the product have the two protons. This radical now again abstract the one proton from these electrolyte solution. So one electron in the system. So it forms the negatively charged at the position. And once this forms the negatively charged, so if you add the isopropyl iodide in the in the reaction, it give the formation of the IPR substituent. So this isopropyl methyl. So this is the sorry the iodide. So this substituent get added to the, so this negative charge attack on these secondary carbon and this iodide get eliminated as I negative. So we get this product. So option C is the correct option here. Then next question is which intermediate involved in the following reaction? So this similar question we have seen earlier also. When this amine react with the NaNO2, it forms the N2, right? So the intermediate will be this N triple bond N plus, so which is a good leaving group. Now, since in the reaction there is an acid OH, so this elimination takes place by this manner. So it forms the benzyme intermediate. So this is the benzyme intermediate, and when this benzyme intermediate react with the, it gives the formation of this product. So right, so this is the product formation. So intermediate is the benzyme intermediate. Option D is the correct option here. So in the next question also the same. This Mg, the Mg react with this compound. So the bromine has the more affinity. Sorry, this bond is more uh, feasible to break in place of the magnesium metal. So this forms the negative and the Mg, Br, this positive. So here there is a fluorine and this fluorine get again eliminated. Again, it forms the benzyme also in this case also. This benzyme intermediate form, which then react with this transchloro, and when it react with the transfluoro, so if you look at this, this is the thermal under thermal condition, and this is the 2 plus 2 cycle addition reaction. So it gives the mixture of the product. So option C is the correct option here. So it gives the both syn and the anti-dichloro substituted compound. The next question is major product formed in the following reaction. If you look at the starting material which has the cyanide group, if I just draw the full structure of this RC triple bond N, so this is the C which has the 1, 2, 3 bond, the enter N, and ethyl magnesium bromide which has the, so this is the negatively charged. So CH2 negative, CH3. So this ethyl group attacks on this electrophilic carbon. So it gives the formation of the C double bond N negative. And here there will be CH2 and CH3. So this aromatic ring remain as it is. Then it react with the, let's say, under workup, acidic workup. So it gives the this imine bond cleave to form the ketone, right? So this is the product form. So which option is the correct option? So you can tick out that one. So option B is the correct option here. Here you can look at the detailed reaction mechanism. Right. So the first formation of this negative charge. So obviously this counter ion Mg positive will be stabilized. So iminium salt complex. Then the after workup, it forms the imine, and further imine, and then imine can convert into the ketone under workup condition, right? On in place of water. So this is the option B is the correct option here. The next question is regarding the we have the ester with the at the beta position there is a bromine and interact with the zinc. So we have seen a similar question. So when it react with the zinc, what will happen? So I'll just draw OET double bond O here negative and ZnBr positive. This ZnBr when it react with the we have the benzaldehyde. So better draw only pH double bond O H. This negative charge now can react with the alcohol, this carbonyl part. So now we have the ET, this ester as it is, this part is also as it is, and from the benzaldehyde, now since this negative charge attack on the benzaldehyde, it become negative, and this phenyl ring will be remain as it is. This proton also remain as it is, and this negative will be Zn, Br will be counter anion get stabilized. Now, if you look at the structure, so this O negative, this will be the 1, 2, 3, 4, and the 5. At the 5 position, there is a good leaving group OET from the ester. So this O negatively charged oxygen attacks on the carbonyl center. It leads to the formation of 5-member ring. And if you look at this 5-member ring structure, so there will be a hydroxy group which has the hydrogen and the phenyl ring. 1 carbon, 2 carbon, 3 carbon, and there is a carbonyl group, right? So this is the, if you look, just give the numbering. This is the oxygen 1, 2, 3 number carbon, 4 number carbon, which is alpha to the carbonyl, and the fifth position is the carbonyl group, right? So this is the product formed in the reaction. So which one is the product? Option A is the correct option here. So option B is just for confusion. So there will be no any involvement of double bond. And in this case also, they have increased one proton, right? So this is also not the case. So option A is the correct option here. So you can look at the detailed reaction mechanism from this one. Right. So we'll move to the next question. Which is again that the same question that we have taken, the first question. So the addition of the BH3 to the carbon-carbon double bond is the in the form of anti-Marconi crop addition. So because of this transition state. So does anyone have any doubt regarding the week 12 topic which is covered or anything regarding this course any doubt regarding the topics which are covered in this course? In the week 12 assignment, are simple questions. So I will take some sample problems from the week 12 also. So here is the one question that is in the assignment. So this N2 we can draw in this fashion also. This N, and there will be a negative charge and the cation. Sorry, not in this fashion. This will be the positive and this will be the negative, right? When we have only two bonds. Right. So here, so this is the structure. So which has this N is negative and this N is the positive. So in this case, what happened? So when this bond pair of electron move to stabilize this carbon positive charge on the nitrogen. So the first will draw the opposite way. So this negative charge involved here. So this bond pair electron goes there. So we get a this 5-member ring with the negative charge, and this nitrogen remain positive as it is. So now here we have the nitrogen positive and the carbon negative. But this double bond to stabilize this positive charge. So in terms of the light, so this will eliminate as it is. Now we have the one negative charge and one vacant orbital, right? One carbocation. So that will be we state as a carbene. So here the carbene is takes place because this both the bond pair of electron from these compound from this carbon and nitrogen bond will be goes to the nitrogen, and only the negatively charged remain on the this cation. So negative charge means those two electrons. So this is the two electrons. So this is the free radical, and when it react with the this is the carbene, and when it react with the double bond, so obviously it will form the when you have the carbene and the double bond. So homologative bond formation takes place to gives the in this fashion. So that's the sorry 3-member ring formation takes place in this reaction. So the intermediate involved is the uh, carbene intermediate. Similarly, there are question number 4 also in the assignment. So predict the major product forming the following reaction. So this is the in the question number 4. I think we have covered this question also. So this question involved the carbene formation. Right. So this is the question, and this type of question that I think we have already covered. So if you look at the in this question, So this entire group is the good leaving group. And when you add the strong base, what will happen? It abstract the proton uh, either from this proton or this proton. So it forms a negatively charged. So I'll just draw here OMe. Let's say this proton which highlighted in the red, if it is abstract that proton, so it will form the negatively charged here, and S positive, this entire group will be there. So this proton formation bond, sorry, this negative charge involved in the double bond formation, this entire group get eliminated and it forms the benzyme. Right. So this benzyme is now, when it react with the furan. So what is the structure of the furan? So this is the furan. There will be a 4 plus 2, 4 plus 2 cycle addition reaction, and it gives the formation of, so this will be the OMe, this is the chloro, and at this position there will be a 5 member, sorry, this will be the furan, and the bridge head, the oxygen will be remain as it is. So this is what we get the product. So option A is the correct option here. This question I think we have covered already. Also the first question also the same, which the first question is, which of the following represent correct order of stability of carbon ion? So we have the three carbon ions, sorry, carbocations, and what will the stability order? So I don't think I really need to explain this question also again, because if you look at the carbon ion, so this is the anti-aromatic, right? So 4, 5 electron. This is the aromatic. It gets stability due to 4 plus 4n plus 2 pi electron. That's the rule for aromaticity. So n is equal to 0. If you put here, there is 4 plus 2, 6 pi electrons. So if you look at in the compound, there are 6 pi electrons. So it get stability due to aromatization. So the 3 1 is the most stable compared to the 1, and then the least stable is 2 second. So 3, 1 and the 2. So option C is the correct option here. So this is the unstable one. And the radical, which is the benzyl equation at the benzyl equation, which get the stability because it get delocalized in the aromatic ring. Also in the second question, this question is again based on the rearrangement reaction that already we covered. The third question, the answer is the carbene. Fourth question that we have already solved. The option A is the correct option for that one. The question 5 is the right. So this question 5, when this we add the LDA, this LDA is the strong base. So when you add the LDA, it attracts the alpha proton of this ester. So I think this question uh, needs some explanation. So if you look at so this is the question. We have the strong base which abstract the proton from this position. We get so this is the methyl, and this will be the O negative, right? This enolate is getting formed. Instead of directly drawing the enolate, better I will draw intermediate. Right. So this anion at this position, it will form the negatively charged because of this strong LDA base. Now we have the pH, yes, SPH. So what will happen? So this bond, so this negative charge now can attack either the sulfur and get remove this one. So This is what it forms. Now, how this reaction proceed further? So that's the question. So here, so either only this reaction either move only up to B or proceed further. That's I don't think it can proceed further because there is no any reagent also given. So I think option B is the correct option in this question. So reaction doesn't proceed further. But I recommend to check all the possibility instead of directly clicking the option A. Sorry, option B. Also, in the question number 6, there is a reaction, Wittig reaction. So that reaction we already covered, and this is the keep in mind this is a stabilized Wittig, so it will form the E alkene as a major product. So in this one, so I hope you will get the answer if you just remember what does E alkene gives. Stability. So it gives the E as a E alkene as a major product. Then question number 7 is reaction of this. We have the acid plus alcohol in the same reaction, and then we have added the SOCl2, then followed by the. So this is the question, and in this one we have the acyl group and the ester group. So in place of SOCl2, this acyl group convert into acyl chloride. Ester group remain as it is. Now when we add the Me2Culi, and so obviously this question is about reactivity and particularly one equivalent. So this particularly go to the center, and we get the Me to Londo as a major product. So if you add one equivalent, but here there is no any equivalence mentioned. So if you consider it is in excess, so obviously the first one will also convert. Then we have the ester. So the ester can also now get attacked by the this methyl negative. So there will be one methyl first addition, second addition, and this will be the OH. Not OH. This can stay up to, I think, only the ketone after addition of another one equivalent of the. So this is after the first. It's up to the second addition of this Me2Culi reagent. Then in the question number 8 is the reaction of the formylation reaction with the uh, we have the anisole and DMF POCl3. So that will be a formylation reaction, and it will go to the para position of this electron donating group. So that you need to keep in mind. Then we have the question number 9. We have the ketone followed by the uh, allylic TMS and water. So this reaction, what will the product in this one? So right, that product also quite straightforward. Then question number 10, that the similar example that we have already covered, the cyclization reaction. Question number 11 also, we have the butyl lithium, and this is just butyl lithium on the pyridine derivative. So I don't think that really need to give much attention on the question, because the butyl lithium abstract the orthoproton of this pyridine. And question 12 is again example of the Grignard reagent, and here the question of the selectivity. So what will happen? So I think that question also we have covered, because we have the aldehyde in the question number 12, 12 aldehyde as well as the ketone group. So obviously the if you had only one equivalent, so the keto group, where the addition of the one equivalent of these Grignard reagent takes place, whether it is on the keto or on aldehyde, sorry, on the ester. So that's the question. So this is on the selectivity of the functional group toward the Grignard reagent. So I hope we have covered most of the problems in the last 12 weeks. So each week we have covered around 12 to 15 problems. So you have total 100 plus problems covered. So you can able to access the OneDrive, and you can access the presentations from the OneDrive. So just look at the problem that we have covered in the this uh, weekly interaction session, and the mostly the assignment will be, sorry, the exam will be have similar questions. Most likely nearly 30 to 40% question will be come from the same assignment questions, whether you have solved the assignment question, this you have already solved that question a weekly basis, right? And also from the courses, the question that I have covered in such sessions. So 50% will be the repeated question from this one only. So we have 12 assignment question, 12 uh, weeks and 12 assignment. So 140 questions from that one, and also the 140 plus question that I have covered. So total 300 questions. From the 300 question, there will be a your question paper will be from that one, majorly from that one. So we'll stop here for today, and best of luck for your examination.
Sir, please explain
Uh,
uh, assignment 11, question number 3.
okay, assignment 11, question number 3. So we'll see assignment number 11. So in the assignment number 11, and right, so this is the question. I will take it on the right. So I think we have also discussed the same question, but that time we have not reached up to the final answer, because this is the alcohol group, and we have added the POCl3 and the in place of the pyridine. So what will happen? The pyridine is the base. So this uh, alcohol is react with the PO for phosphorus. So this O P bond formation takes place. So there will be double bond obviously there, and Cl and the Cl. One Cl negative is eliminated. Right. So up to here is okay. So we have also reached that time also up to here. But now the question is next, what will happen further this one? So if you look at the this one, so this CL doesn't uh, really attack on directly that we as we there is one possibility of getting such product. But in this case, what happen because of this pyridine, it will show elimination reaction because this since this group is formed, so this is also one of the Goodling group, this O P bond. So the driving force for this one is this type of elimination is the OP bond formation, and we get this as a product. So in this case, option B is the correct option here. And I think you have also get the assignment solution for this one also. So
Sir, in the assignment solution, correct option is B.
right, this is the one, right? That we are getting. Yeah. So option B is the correct option, right? So that's what we are getting because of the pyridine. This proton pyridine abstract this proton, then it will form the SN2 type of E2 type of elimination. We get the eliminated product.
ओके सर। सर
Mm.
असाइनमेंट से 50% क्वेश्चन रहेगा क्या?
Majorly the assignment that let's say there will be a 12 assignment, right? So from the 12 assignment plus 0 week 0,
30।
12 question. So there will be a 150 plus questions, right, from the assignment this year, right? And also the question that I have covered around 150 plus question, 150 question that I have covered. So that you have the Google Drive link which contain my presentation slides, right?
अराउंड 300 प्लस क्वेश्चन।
So total there are exactly so 300 questions. But if you look at the questions that I have covered and the assignment, the question is in the your assignment, nearly similar question because the concepts are the similar concept used in the all the question. So there, if you look at the distinguished category of question, that will be only uh, 70 to 80 questions because there will be repetition of same concept. And so the mostly exam will have nearly repeated question around 20 to 30%, I can say, because my experience from the last few years. So nearly 20-30% question will be repeated. And then the concept will be 40% repeated concept. So you are definitely able to get very good marks in the exam in this. If you have look at the if you just have seen my presentations, 12-week presentation slides. So the question that we have covered and also 12 assignment solution that already is in the portal. The if you look at the itself the on the portal, you will get there is one assignment solutions also given, right? So let's say each week have their assignment solution. So you can download that assignment solution. So from you can also only if you just study that one, so that will be good enough to get you good marks.
ओके सर।
So this week also assignment questions are also easy, not that much difficult, right?
ओके।
And yeah, so we'll stop here for today, and then best of luck for your examinations.
थैंक यू सर।
Yeah, and also I'd like to uh, highlight if you need any help, any like not only for this course. So this is my contact details. So you can I recommend to reach out to me if you have anything you need, whether regarding this course or any information regarding these any stuff regarding the IIT Delhi or maybe from this joint kind of PhD or also from the PMRF. Yeah.
Thank you.
Yeah. See ya. Thank you so much.
Okay.